Hi guys, in today's video we're going to be talking about factorials once again because this topic is quite important for especially for permutations and combinations, which I will be taking on some other day. So for now I'm going to be talking about what are factorials, and I'm going to be giving you some questions. So what are factorials? Factorial is basically the multiplication of a number and every number before it. So say you have 5 factorial. So 5 factorial means the multiplication of 5 times 4 times 3 times 2 and times 1. So the multiplication of every number before it. Same way is 3 factorial, which is 3 into 2 into 1, and 4 factorial, which is 4 into 3 into 2 into 1. So yeah, that's basically what factorials are. Okay, so how exactly were factorials made? So factorials are the amount of ways you can arrange a certain number of objects. Arrange objects ways. What does that mean? That means if you have 5 boxes, all of a different color, let's say, let's call them 1, 2, 3, 4, and 5. So the total number of ways you can arrange these boxes in different methods obviously will just be 5 factorial, which is 5 into 4 into 3 into 2 into 1. Now I'll tell you why 2. So if you have 5 boxes, so we will have 5 ways to arrange the first box, right? One is here, second position will be here, it'll be here, it can be here, it can be here. So that's 5 ways you can arrange the first box. Times, if you come to the second box, we can arrange the second box in 4 ways because 1, 2, 3 and 4. And same way, third box we can arrange in 3 ways, second box in 2 ways, and third box in 3 ways, fourth box in 2 ways, and fifth box in only 1 way. So the total number of arrangement of these boxes will just be 120, which is 5 factorial. So I'll give you some questions now. Say you have 5 factorial plus 4 factorial. What do you think this will be? 5 factorial is 120, 4 factorial is 24. So it will be 144. Okay. That's basically what factorials are all about. The arrangement of objects. So the number of ways you can arrange an object. Alright. I have a couple of questions for you now on factorial. So say you have n factorial. How would you expand n factorial? Remember, factorial is the multiplication of that number and all the numbers before it. So n factorial is just n times n minus 1 times n minus 2 times n minus 3 all the way till 3 into 2 into 1, right? Same way, n minus 1 factorial is just equal to n minus 1 times n minus 2 times n minus 3 all the way till 3 into 2 into 1. So if you can see over here, can you see anything common between n factorial and n minus 1 factorial, the expansion? This and this is exactly the same. So that means n factorial is just equal to n times n minus 1 factorial, right? Because over here you can see this is n minus 1 factorial and this is the same thing, n minus 1 factorial times an extra n. and that's equal to n factorial. So we can say n factorial equals to n times n minus 1 factorial, which also makes sense because n factorial is just n times n minus 1 times n minus 2 all the way till 3 into 2 into 1 and n minus, and yeah, one second, and n minus 1 factorial, n minus 1 factorial is just equal to n minus 1 times n minus 2 all the way till 3 into 2 into 1. So all these terms from n minus 1 till 3 into 2 into 1, everything in between is just common, and on top you just have an extra n. So we can say n factorial is equals to n times this, when this is just equal to n minus 1 factorial, n times n minus 1 factorial, right? So that way we can also say n factorial equals to n times n minus 1 times n minus 2 factorial, right? Same way we can say n factorial equals to n times n minus 1 times n minus 2 times n minus 3 factorial. You can say that too. Basically that's the correlation between the two, or how many ever you got. Okay, so I've got a practice question now. So evaluate n over n plus 1 over n factorial. Okay, n plus 1, n fact, when we expand n factorial, what do we get? N times n minus 1 times n minus 2 factorial, and that's the answer for this. That's it. All you have to do was expand. Here's another one. N plus 1 divided by n plus 2 factorial. Okay, so when we expand n plus 1, what do we get? We get n plus 1. Sorry, when we expand n plus 2 factorial, we'll get n plus 2 times n plus 1 times n factorial. We can cancel n plus 1 and n plus 1, and all will be left with is 1 divided by n plus 2 times n factorial. Okay, here's another one. Oh wait, yeah, here's another question. Say you have the summation of r into r factorial from r equals to 1 to n. This is an interesting question, so let me just rewrite it better. The summation n of r into r factorial. How would you do this sum? Alright, you could rewrite this by using algebra, or yeah, algebra only. You could rewrite this as r plus 1 minus 1 times r factorial, just to solve it ahead. Oh wait, so this, you could rewrite it like this. So this would be equal to, what is r plus 1 minus 1? Think. So when we could rewrite this as the summation from r equals to 1 to n of r plus 1 factorial minus r factorial, right? Because when you multiply this, you get this. So now, so this is our last step. So this equals to we can separate the summation now because we have a minus sign in between. So r plus 1 factorial minus the summation of r factorial from r equals to 1 to n. What is this equal to now? Now we can expand. So this equal to, right? Oh wait, plus uh, right? When we expand the top, we get this. I just flip the sides. So our final answer. So you can cancel terms. See, in n factorial, somewhere you will get 2, right? Or let's not say it that way. I'll just say you can cancel this 2 factorial by this 2 factorial. This 3 factorial and this 3 factorial will get cancelled. Um, yeah, so this n and this n, right? So our final answer would just be n plus 1 factorial minus n factorial. I'm not going to explain this so much because I want you guys to do it intuitively. That helps a lot. Okay, suppose if the LCM of 8 factorial, 10 factorial and 12 factorial equals to L, and the HCF of the same numbers equal to H or H, find L over H. So we need to find LCM over HCF. Okay, LCM is the lowest common multiple. So if you can tell this 8 factorial and 10 factorial and 12 factorial all are multiples of 12 factorial, right? If you look carefully, same way 10 factorial, 12 factorial and 8 factorial are all the common factors, or yeah, are all the common factors of 8 factorial, with the highest common factor being this of 12 factorial. Sorry, hold on. So if you take, I said that wrong before, if you take the multiple or highest multiple of 12 factorial, lowest multiple, sorry, that will just be 12 factorial, and the highest common factor of 12 factorial would just be 8 factorial. Therefore all we have is L over H is equal to 12 factorial by 8 factorial, which is when you evaluate you'll get 12 times 11 times 10 times 9 times 8 factorial. Oh wait, hold on. Yeah, as I was saying, you'll get times 8 factorial divided by 8 factorial, so these both will cancel. So your answer would be 12 times 11 times 10 times 9, which is equal to, when you evaluate, till 11880. Yeah, okay. So that's it for this question. All you had to do was it was a more of an intuitive question, to be fair, but okay. Now I'm gonna give you some important rules for factorials which you should know laws, basically, sort of. First law is the n factorial is equals to n times n minus 1 factorial, which equals to n times n minus 1 times n minus 2 factorial. Second, 0 factorial equals to 1, which equals to 1 factorial. I'll make a separate video about this later. Why 0 factorial equals to 1. Third, 2n factorial. We can rewrite this as 2 raised to n times n factorial times 1 into 3 into 5 till 2n minus 1. Fourth, n factorial by r factorial is equal to n times n minus 1 times n minus 2 all the way till r plus 1. Oh, and this law is only applicable if r is smaller than n. You have to remember that too. Fifth, n factorial divided by n minus r factorial is equal to n times n minus 1 times n minus 2 till n minus r plus 1. Right? Sixth one, 1 by n factorial plus, sorry, this should be plus 1 by n plus 1 factorial is equal to lambda, or basically a number, divided by n plus 1 factorial, then lambda is equals to n plus 2 whole squared. So if this plus this equal to this, then lambda, which is in the numerator here, is equal to n plus 2 squared. And our last one, if x factorial equal to y factorial, then that means x equal to y or x equal to 1 comma y equal to 0 or x equal to 0 comma y equal to 1. And this is because 1 factorial is equal to 0 factorial. They both are 1. Yeah, and that's it for this video.